In this example, we are given the categorized data of some magazines and are asked to test if they are equally popular. 5 different magazines are selected, so K is equal to 5. A sample of 300 students is observed, so N is equal to 300. Alpha is given to be 5%. Since we want to test if all 5 magazines are equally popular, our null hypothesis should state that the proportion of popularity for the 5 categories P sub 1, P sub 2 to P sub 5 are all equal and is equal to 0.2. The alternative hypothesis should then state the opposite, which is at least one of the P sub i's is not equal to 0.2. Based on the scenario, we came up with the null and alternative hypothesis. Since we are testing if the data fits the model, we'll use the chi-square distribution for our analysis. Using alpha at 0.05, the right tail area becomes the rejection region. To get the degree of freedom of K minus P minus 1, we note that there are 5 categories, so K is equal to 5. P is the number of population parameters such as mu and sigma that is being estimated from the sample data. In this case, P is equal to 0 since none of the population parameter has been estimated. Hence, df is equal to 5 minus 0 minus 1, which is equal to 4. Next, to get the critical chi-square value, we use the chi-square table. Look for degree of freedom of 4 and the right tail probability alpha of 0.05. Pick up the corresponding value of 9.488, and that becomes the critical chi-square value, which separates the rejection and the non-rejection region. Next, we find the test statistics chi-square star. The categorized data are given as such. These are the observed frequencies O sub I. To get P sub I, which is the probability or the proportion of each category, we look for the null hypothesis and pick up the P sub i's for each category. In this case, all the P sub i's are hypothesized to be equal to 0.2. The probabilities for all 5 categories should add up to 1.0. To get the expected frequency E sub I, the formula is given as n times P sub I. N is the total sample size of 300. So for the first category, we take n of 300 and multiply by P sub 1 of 0.2 to get 60. For the second category, we take n of 300 and multiply by P sub 2 of 0.2 to get 60. Do the same for the rest. The expected frequencies for all 5 categories should add up to the total sample size of 300. Next, we find chi-square star. The formula for chi-square star is given by this formula, which is the summation of all the 5 categories. So let's find the squared difference between the observed and the expected frequencies divided by the expected frequency for each category. For the first category, we substitute O sub I with 80 and E sub I with 60 to get 6.667. Do the same for the other 4 categories. Finally, to get chi-square star, add the whole row together to get 12.5. So we have found the test statistics chi-square star to be equal to 12.5, which is somewhere around here. Since it lies in the rejection region, H0 is rejected at alpha equal to 0.05. And we conclude that there's strong evidence to show that not all magazines are equally popular at 5% significance level. In fact, based on our table, we can see that teen magazine tends to be more popular than expected.